Now let's also do the exercise together. So the exercise is again just a recap of the whole procedure, like the whole steps we did today. But instead of based on the iris dataset, so that's just a flower dataset, right? So here we will be based our practice, our exercise on the financial dataset. So first, for our exercise, oh, sorry, we are going to actually import our data first. So we are importing the file called as mldata.zip, and that zip file contains gross profitability, quarterly EP, and also the momentum data and our volatility data. Also, like our outcome variables. Our outcome variable contains 3 categories. The first category being in the top, like the company's performance will be in the top, is classified as 3. And also if in the next year, the company's performance is going to be in the middle, then it's classified as 2. And also our outcome variable will be classified as 1 if the company's next year's performance is actually at the bottom. So first we load the data. Also, we are setting the index being ID and date. So we are just using pd.read.csv, and we are importing this zip file, and we set past dates being equal to the date column. The whole purpose of this parameter here is that we are trying to create datetime objects, right? Because we might perform calculations based on dates. So that's why we want to create datetime objects. And that's why we want to pass dates. And then we also set the index based on our stock ticker, so ID, and also the date. We have 2 levels of the index. Then we are defining our features and outcome variable. So as you guys can see from the previous discussions, whenever you are using scikit-learn, you would be creating an object for the features and another object for the outcome variable. So here you are storing the features in X and you are storing the outcome variable in Y. So the features are the GP, so the profitability, the momentum, the EP ratios, and also the beta values. So that's your features. And then for the Y, that's actually the group column. So we let Y being equal to the group column of data. Let's execute the code here. And now a second thing we need to do in the first step is that we need to do the train test split. So here, let's just input X train, X test. And then Y train and Y test. So those are the 4 outputs. The training data set of the features, the testing data set of the features, and the training data set of the outcome variable, the testing part of the outcome variable. And we are using the train test split function from scikit-learn. And as for the inputs, our first input is going to be our features, that's X, and our second input is going to be Y. That's our outcome variable. And then we want to set the test size. Let's just let the test size to be equal to 0.4 as before. Then we also set the random state. So remember that the random state is sort of keeping our partition being the same for each time that we are running the notebook. That's basically because the train test split is actually doing the splitting randomly. So if you don't set the random state to be equal to a fixed number, so if you don't do that, then basically your partition of the training and testing data set will vary from time to time whenever you are rerunning the notebook. So here, let's still set the random state being equal to 4. Of course, you can set it to be equal to whatever number you want, but in that case, your results will be slightly different from mine because you are essentially doing the training and the testing based on create different split. Now let's initiating the model. So remember that initiate is all about an object based on the template, based on the class. So here we create an object called as new KNN, and we let it to be equal to K. So remember that we already imported the K neighbors classifier. So we let it to be equal to K neighbors classifier. And inside that class, we are specifying the hyperparameter, which is essentially the K. So we specify so as you guys can see that the requirement is that we set the K to be equal to 25. So we let n neighbors being equal to 25. The step 3 is that we are training the model. So let me execute the code first. Now we are just using the feed method. We are just training based on the training data set. So based on X train and Y train. So new KNN. And then we are just doing fitting. So dot fit. And then inside that, we input 2 things. The first thing is our X train. The second thing would be Y train. So we are doing our training based on the training data set. Then we will be doing out of sample validation based on the test data set. Now let's first create predictions. And then let's just use the accuracy score to generate our performance measure. First, Y pred is going to be equal to mu KNN. And we are again using the predict method. So we are using the predict method of our mu KNN model. And also we are predicting based on the test data set because we are doing the out of sample validation. So essentially we are generating all our predictions based on the data set that so far our model has never seen. We are using features in the test data set, which is X test. Now let's also generating our performance measure. In this practice here, we are creating the out of sample accuracy. So we are just using the accuracy score from matrix. And also, as I said earlier, for accuracy score, basically you're calculating the ratio of the correct predictions over the total observations. Or in other words, you are comparing how close are the distance between the predictions and the actual outcome variable values, the actual labels. Therefore, the 2 input for the accuracy score are just going to be the predictions and the actual labels. So our first input is going to be our actual labels. That's going to be Y test. And then the second input is going to be our predictions. So that's Y pred. So here, our accuracy score is 0.3848. That doesn't seem high, right? But this is somehow actually a good accuracy score. It's at least better than random. So here we are having 3 classes. So remember, I think 3 being outperforming and 2 being like the companies that perform in the middle. And the bottom, like the one representing like the company's performance that are in the bottom. So here, if you are like having an estimator that is doing random guesses, so in that case, that random guess estimator is going to have a 33.33% of chances of getting that prediction right. But here our accuracy is actually higher than that 1/3 of a correct probability for the random guesses. So essentially our estimator here is better than a random guess. Now the final step is that we are going to do the hyperparameter tuning. So we are doing the hyperparameter tuning based on our financial data sets. Here we are testing the values between 25 and 250. So like the number of neighbors will be varying between 25 and this huge number of 250. And also we want the increment to be 25. So basically, we want to testing the number of neighbors being 25, 50, 75, so on and so forth. So the increment is going to be 25. And the rest will be pretty much the same as what we did for the flower dataset. Now let's do that. We again create an empty list. So that's a list we want to store our results for each of the hyperparameter. We create an object called as optimal. And now let's start coding our loop. So for the loop, we already have a hint here. Let me just copy that. So for k in range 25 till 275 with an increment of 25, that's our for loop. And inside each of the loop, for each of the iteration, first we are going to instantiate the classifier as usual. So we instantiate the classifier. So let's name it as kn2. kn2 being equal to k neighbors classifier for each of the iteration. We just set the hyperparameter here being equal to k. Then we're just going to testing the performance for each of the k. So as before, we're just using the k-fold cross-validation. So the requirement asking us to calculate the average accuracy score for each of the k using the 10-fold cross-validation. So let's do that. So let me also write the comment here. We run the 10-fold cross-validation. Now we let k scores being equal to cross var score. So remember that's a predefined function just inside scikit-learn. And also for the inputs, the first input is going to be the classifier we just instantiated. So that's going to be kn2. And then we are also feeding features into this function. So that's going to be x. And then our third input is going to be the outcome variable or the label. So that's going to be y. And then we set CV being equal to 10. So remember that CV is basically specifying the number of faults in the k-fault cross-validation. Here we want it to be equal to 10. So CV equal to 10. The k-scores will actually contain 10 accuracy scores for each of the k, right? For each of the iteration. So what we really want is the average accuracy score. So what we really want for each of the iteration is just k scores don't mean. And here we are storing this average accuracy score in this empty list in the optimal object here. So we let optimal being equal to, we are not only appending the average accuracy score, we are also appending the current number of neighbors. So for example, if we are at the first iteration, that's going to be 25 here. What I'm trying to say is that we also want to append the k to the optimal object. So here we actually use the append method for optimal, because like remember optimal is a list. So we are using the append method for a list, and then we are appending like both the indicator variable for the number of neighbors. So that's going to be k. And also we are appending the average accuracy score corresponding to that specific number of k. So essentially we are appending the average accuracy score for each of the values in this range, like 25, 50, 75, 100, so on and so forth, like until 250. Let me also write the comments for this appending line of code here. We are saving the average accuracy. And of course, as I said earlier, the number of neighbors. Now, finally, we will be transforming that output list into a data frame as what we did before. Actually, let me execute that for loop first, and then I will be showing you guys the list again. Sorry, the code is still running now. I'm just gonna pause a bit until the code finish running, and then I will go back to expanding the rest here. Okay, the code finished running now. So let's have a look at the optimal list. As I pretty much described earlier, now inside the list, for each of the iteration, we're going to have the value of the k, and also that's the number of neighbors for each of the iteration. And we also have the average accuracy score. So then we are just creating a data frame based on this list, because you guys know that the whole reason for creating the data frame is that data frame can directly do the plotting, right? Because the pandas data frame actually has plot method, so we don't have to use matplotlib directly to do the plotting. So now let's just create a data frame based on the list here. What we are going to do is that optimal being equal to pd.data frame. So here, let me also write the comments here. We transform the output list into a data frame. So optimal is just going to be equal to pd.data frame. And we are specifying the column names. So of course, the first input is just going to be the list itself. So this list here. So let's just input that. Let's just input optimal being the first input. And then we are specifying the column names. So the column names are going to be like as we specified before, the number of neighbors. And also the accuracy. So that's just like the name for the second column. We also have to set the index for that data frame. So let's just write set index. If we are going to plot out the performance variations across different number of neighbors, then we basically want the number of neighbors being the index. So here we are setting the index as the first column. Let me just copy the first column name. So Control C and Control B here. Then that's creation of the data frame. And then we are just plotting, utilizing, like plotting the average accuracy score like across different number of neighbors, utilizing this data frame. So optimal and then dot plot. Now we are setting the figure size. So fig size is going to be equal to 10.6. You can also modify that to be whatever size you want. And we are also setting the style. So style being equal to R and this short dash and then O. So this R is representing the color being red, and this short dash representing that we are having solid lines. You guys will see what this O represents after plotting out the figure. Let me just continue. So now I'm setting the X label. So X label, that's going to be like the name for the X axis. So we are setting that to be equal to number of closest neighbors. and the open bracket and also close bracket, and inside I put K here. Then I'm setting the y-axis name as well. The y-axis are actually representing the average out of sample accuracy, right? So here we are just setting it as 10 folds. Sorry, 10 folds average out of sample accuracy. Then we also want to set a title for this figure here. So inside the plot method, we are specifying the title parameter to be equal to hyperparameter tuning. Yeah, that's it. Let's just plot the figure here. Oh, column. I think I perhaps just put the column. That should be columns instead of column. So I put that wrong. So here, I think our optimal number of neighbors is pretty much this point, I think. Also, I forgot to discuss about the O here. So the O are corresponding to those red dots, those red points on this figure. So if we get rid of that O, you can see that we basically wouldn't be having those points. So we will only be having a solid line, a solid red line. Huh. What went wrong here? Oh, I guess that's because I execute this line multiple times. Sorry about that. So the data is disappearing basically because I'm creating the data frame based on like the data frame and then the data frame again and again. So I guess that's why my data went wrong. Let me run the loop again. Actually, let me pause here and let me fix the results and I will directly show you guys what's the difference with and without O. Now I fix it. So basically here, that's the result. Like if inside the style, if we specify O, then we are going to have those red solid points, basically those red dots, right? So now if we scroll down, if we look at the results where the style doesn't have that O, then we are having only this red line. So we don't have any points highlighted on this figure. Thank you guys for attending today's session. See you in next session. So we have one more session remaining. Bye.